A Pythagorean triple. Now, I'm assuming that you already know what Pythagorean theorem is. It states that in a right triangle, if the legs are of length A and B, then and the hypotenuse is C, then A square plus B square equals C square. So that's the relationship for a Pythagorean theorem. Now, you may have come across this problem where the legs are 3 and 4 and you're asked to find the hypotenuse. So let's actually do it one more time. 3, 4, and let's call it x. Then you write down 3 square plus 4 square equal to x square. And when you follow the order of operations, you have to do the squares first and then you have to do the additions. So 3 square is 9, 4 square is 16. And now you can perform the addition. 25 equals x square. And to get rid of the square, you take the square root on both sides. So x is square root of 25 or x is equal to 5. Now I can write down my side lengths are 3, 4 and 5. So usually you don't get these nice integer numbers for the sides of a right triangle. But whenever you get, then it's called a Pythagorean triple. So 3, 4, 5 is an example of a Pythagorean triple. Now the advantage of knowing this Pythagorean triple is you can use this to do so many other problems. For example, even if the side lengths are not 3 and 4, but say 6 and 8, then what is the side length here? Well, you can say that this is the double of 3, that's the double of 4, so this has to be the double of 5. So that would have to be 10. And without doing it, without writing down the theorem and then showing all these steps, we can get right away. So let's look at some more triangles where we can use this Pythagorean triple. Now there are several other Pythagorean triples, but the most common is 3, 4, 5, and probably that's what you're going to see on your SAT. Now, I don't even need the question may not always be you're given the legs and you're asked to find the hypotenuse. Sometimes you might be given the hypotenuse and a leg. So say this is 50 and this leg is 40 and this is the missing side. Now when you have numbers like that, remove the common factor or the greatest common factor. What's the greatest number that goes into both? And it's 10. This is 10 times 5. This is 10 times 4. So now I know this has to be 10 times 3, which is 30. So I can write down the answer right away if I know my multiplications, of course. So let's try some more examples. And again, your right triangle need not always be oriented in the horizontal and vertical direction. Sometimes your hypotenuse might be horizontal. So look out for this square box. So that tells me that these are the right angles, or these are the legs. So now let's say I've been given 30 for the hypotenuse and 18 for one of the legs. Now what's the greatest common factor between 30 and 18? In which multiplication table do you see both of these? You might say 2 goes into both, but I want to know the biggest number that can go into both. That's called the greatest common divisor. And 3 also goes into both, but the 6 goes into both of these. This is 6 times 3 and that's 6 times 5. So again, when you remove the common factor of 6 Do you see 3 and 5? Then you got to have 4 here. So if one leg is 3, hypotenuse is 5, the other leg has to be 4. This is 6 times 3, 6 times 4, so this would have to be, this is 6 times 3, 6 times 5, this would have to be 6 times 4, which is 24. And notice that you can actually do it much faster than what I'm saying, because I'm saying just to slow down. But you might quickly recognize the greatest common factor of 6, and then you can write this right away without using calculator, provided you know your multiplication tables, of course. So there is some advantage in knowing your multiplication tables. Let's try some more. So this time again, I'm drawing my right triangle this way. So say I have 300 and 400. So if the legs are 300 and 400, the greatest common factor is 100. This is 100 times 3, 100 times 4. So this x would have to be 100 times 5, which is 500. All right, let's try one more. And in this video, I'm only discussing this Pythagorean triple, 3, 4, 5. Now, there are several others. In fact, you can get as many Pythagorean triples as you want, but our focus is on the SAT, and this is the most common one, 3, 4, 5. So, say this is 16 and that is 20. So the hypotenuse is 20, one of the legs is 16. The greatest common factor, the greatest number that can go into both is not 2, but 4. This is 4 times 4, 4 times 5, which means if I remove the greatest common factor, then I'm mentally erasing the 16 and writing a 4, and I'm writing a 5 here. So if I have 4 and 5, I got to have 3 here, because it's 3, 4, 5. But I'll include that factor of 4. So it is 4 times 3, which is 12. So this was the missing side. Okay, let's try this one, where this time I'll say this is 100 and this is 80. So what's the biggest common factor? 10 goes into both, but 10, there's a bigger number. If I divide both of these by 10, I get 10 and 8. And again, 2 can go into both. Then this is 2 times 5, that's 2 times 4. So this corresponds to 5, this corresponds to 4, which means this should correspond to 3. But it's 3 times what? Well, this was 20 times 5, 20 times 4, so this would be 20 times 3, and that is 60. So let's say this was the missing, and we just found it to be 60. Now, I think this is what I have. Some practice problems on the 3, 4, 5 Pythagorean triple. Find the missing side x, and there's nothing here. That's an x. And I have 9 problems. I'll put down the answers in the video description. So try them and try to use the Pythagorean triple. You don't have to work the Pythagorean theorem. And you probably don't even need calculator. All right, that's all I have for this video. I'll see you in another one. Thank you.